In this video, I am going to discuss about the initial and final value theorem which are associated with the Laplace transformation. So let me start with initial value theorem. If Laplace transformation of f of t is fs, then limit t tends to 0, f of t will be nothing but limit s tends to infinity s into fs, provided the limit exists. If these two limits are same, then I can say that the initial value theorem is verified. When I am talking about initial value theorem, you see that t tends to 0. So if I am taking t tends to 0, then I have to take s tends to infinity. So that is the meaning of initial value theorem. Initial value means t equal to 0. And what is the final value theorem? The final value theorem states that final value theorem. Final value theorem states that if Laplace transformation of f of t is fs, then limit t tends to infinity. Final value means t will be infinity. F of t is equal to, when I am taking t tends to infinity, this time this side will be s tends to 0. S into fs. S into fs. And this is called final value theorem. This is called final value theorem. So in the question, you will have like this: verify the initial value theorem for f of t equal to 3 minus 2 cos t. So suppose this is my f of t. So in order to verify the initial value theorem, let me first find Laplace transformation of f of t. So Laplace transformation of f of t is equivalent to saying Laplace transformation of 3 minus 2 cos t. 3 minus 2 cos t. So let me find the Laplace transformation of this one using linear property. This is equivalent to saying Laplace transformation of 3 minus 2 is constant, Laplace transformation of cos t. Okay. So if I write this one, I will denote it as fs. I will denote it as fs. And Laplace transformation of 3 is equivalent to saying Laplace transformation of k. Laplace transformation of k is nothing but k by s. So here I will have 3 by s minus Laplace 2 into Laplace transformation of cos at is s by s square plus a square. But here in this place a is 1, and so it will be s by s square plus 1. So this is my fs. This is my fs. Now what I will do, I will find s into fs, because in the initial value theorem I have to find s into fs. So I will find s into fs. So what we will get then? S into 3 by s minus 2s by s square plus 1, by s square plus 1. And further we can write this one as 3. I am multiplying s with each term, and then minus 2 s square by s square plus 1. Okay, so this will be my s into fs. Since in the final value theorem I am taking s tends to infinity, you see in the second term s square by s square plus 1 is there, so infinity by infinity form will come. So let me take s square common. So after taking s square common, what we will get? S into fs will be 3 minus 2 by 1 plus 1 by s square. So this will be my s into fs. Now let me take limit t tends to 0 f of t. So that is equivalent to saying limit t tends to 0 f of t is 3 minus 2 cos t minus 3 2 cos t. So if I put t equal to 0, it will be 3 and this one will be cos 0 is 1 minus 2. So I am getting the left hand limit is 1. And then I will find limit s tends to infinity s into fs. And that will be nothing but limit s tends to infinity s into fs we got 3 minus 2 by 1 plus 1 by s square. You see, if s equal to infinity, 1 by s square will be 0. So I will have finally 3 minus 2 equal to 1. Hence, left hand limit, hence, what we got? Hence, limit t tends to 0 f of t equal to limit s tends to infinity s into fs. Therefore, the initial value theorem is verified. Is verified. Okay. So like this we can able to verify the initial value theorem. Suppose let us take another problem on final value theorem. We will consider another problem for final value theorem. The question will be like this: verify the final value theorem. Verify the final value theorem for f of t. F of t equal to 1 plus e to the power minus t into sin t plus cos t. Okay, this is my f of t. So now what I will do, I will verify the final value theorem. I will verify the final value theorem. According to the final value theorem, what we need to see? Limit t tends to infinity, f of t should be equal to limit s tends to 0, s into fs. So let me find first fs, then we will go for the thing. So what I will do here is, my Laplace transformation of f of t is equivalent to saying Laplace transformation of 1 plus e to the power minus t into sin t plus cos t. Using the linear property, I can have Laplace transformation of 1 plus Laplace transformation of e to the power minus t into sin t plus cos t. Okay. Now further I will use the shifting property and I can have the thing Laplace transformation of 1 plus Laplace transformation of e to the power t into sin t plus Laplace transformation of e to the power minus t into cos t. So I am multiplying e to the power minus t with sin and cos, and I am separating using the linear property. So linearity property. And so that means here I will have Laplace transformation of 1 is 1 by s. And then what I will have? I will find Laplace transformation of sin t. And wherever s is there, I will replace it by s plus 1. And similarly, I will find Laplace transformation of cos t. And wherever s will be there, I will replace it by s plus 1 because e to the power minus t is there. And so finally what we will get? 1 by s plus 1 by s plus Laplace transformation of sin t is 1 by s square plus 1. But here that s will be replaced by s plus 1. And here Laplace transformation of cos t is s by s square plus 1. And here s will be replaced by s plus 1. And so finally what will be my fs? My fs will be 1 by s plus s divided by s plus 1 whole square plus 1, sorry, 1 divided by s square plus s plus 1 whole square plus 1 s plus 1 divided by s plus 1 whole square plus 1. So this is my fs, and I can find s into fs, s into fs. So what will happen if I find s into fs? S into 1 by s plus 1 by s plus 1 whole square plus 1 plus s plus 1 divided by s plus 1 whole square plus 1. So if I multiply s with every term, I will get 1 plus s by s plus 1 whole square plus 1 plus s into s plus 1 divided by s plus 1 whole square plus 1. Okay, so this will be my s into fs. Now I will take the final value thing. So limit t tends to infinity f of t, that is equivalent to saying limit t tends to infinity 1 plus e to the power minus t sin t plus cos t. Okay, so whatever thing it may be, if I take t tends to infinity, e to the power minus infinity will be 0. So the limit will be now 1. The limit will be now 1. Now I will take limit s tends to 0, s into fs is equal to limit s tends to 0, s tends to 0, 1 s by s plus 1 whole square plus 1 plus s into s plus 1 divided by s plus 1 whole square plus 1. Now if you take the limit, all the limit of all the terms exist. Nowhere we are getting 0 by 0, infinity by infinity, and so like that form. So we will not do any change. We will put s equal to 0 everywhere. If I put s equal to 0, 0 by something will be 0, 0 by something will be 0. And so finally what will be the limit? 1. Hence limit t tends to infinity f of t is equal to limit s tends to 0, s into fs. Therefore, final value theorem is verified. Is verified. So like this we can use the initial and final value theorem.